Hey guys, Mr. Yisley here. So we're on to lesson number 6 in chapter 2b, all about solving linear inequalities. And this one's going to have some subtraction examples in it. So we're going to go through 3 examples together where we're going to solve them, these linear inequalities, and then we're going to graph the solutions as well. So our process though is the exact same. We're going to go through those exact same 3 steps of finding the variable, figure out what's being done to it, undo it, and then solve the inequality. So when I look at example A, I have y plus 8, which is less than or equal to 5. So first thing, find the variable. Here is my variable right here. Well, what is happening with it? Well, it's having 8 added to it. So if I came over here to make my to-do to undo list, I'd say, all right, well, my variable was being added by 8, right? Well, that was the only thing going on, so I only have one thing to undo. So the opposite of adding 8 is to subtract 8. So the inverse operation of addition is subtraction, and we're going to do it by the same number that they were adding. So instead of adding 8, we're going to subtract 8. Well, there is my step to solve this, so now I need to go in and I need to actually do that. So I'm going to subtract 8 underneath where they were adding 8, and then whatever I do to one side, I also have to do to the other side of the inequality. So I'm going to subtract 8 on this side of the inequality symbol as well. All right, well, once we've gone through that, now we need to solve it. So adding 8 and subtracting 8, those, again, cancel each other out. So all we're left with is the y, so we're going to bring that down. Right? Then we need to bring down the inequality symbol exactly as it is. So less than or equal to. And then 5 minus 8. Well, 5 is good guys, 8 is bad guys, so there's a battle going on. There are more bad guys, so we're going to end up with a negative. And how many more are there? Well, there are 3 more. So I ended up with y is less than or equal to negative 3. All right, well, now our step is we need to go in and graph it. So first thing, we've got to label this number line. So I'm going to start with the number I figured out, which was negative 3, and I'm going to put it right there. Then I'm going to, counting by 2's, switch, or every other dash, I'm going to label numbers. So moving towards the right, that would be negative 2, negative 1, and then 0, 1. And that's enough numbers moving to the right. Now I need 2 to match that moving to the left. So this would be negative 4, negative 5, negative 6, negative 7. So there we go. We've got it labeled. So we're good there. Next step, we need to go in and we need to choose a point to the left of negative 3 and then a point to the right. So I'm going to choose first the point negative 5. I'm going to plug that in for y and see if it comes true. So I've got negative 5 is less than or equal to negative 3. Well, is negative 5 equal to negative 3? No, it's not. But is it less than negative 3? It is. So that's true. So that should mean our arrow's going to the left. But let's just check a number to the right of negative 3 and see if that one comes true as well. So to the right of negative 3, I've got negative 1. So I'm going to plug that in. Negative 1 is less than or equal to negative 3. Well, negative 1 is not equal to negative 3, and it is not less than negative 3. It is greater than negative 3. So this is false. All right, well, we figured out which way the arrows go, so now we need to go back to the original number of negative 3 and draw our circle. Then we need to look, is there any portion of an equals to sign? Yes, there is. So that means this is a filled in circle, meaning negative 3 is a solution to this inequality. Right? And then last thing, we need to draw our arrow moving towards the true side. Well, here's our true side right here. So we're going to have an arrow moving this way, which means everything on this side that way would make this inequality true. All right. Well, now I'd encourage you to try example B on your own and then check your answer with mine. So example B says negative 8 is less than 1.4 plus m. All right, negative 8 is less than 1.4 plus m. So first up, where is the variable? Well, this time, instead of being on the left side of the inequality, it's on the right side. And that's completely fine, right? It can be on either side of the inequality. So I have an m right here. Well, what is happening with the m? Well, this is where when it's the second term, or not the first term, like the 1.4 is, we have to look back at this number right here. And we have to say, okay, is that number a positive or a negative? And we talked about this back in chapter 2. Well, this number is positive, which means it is being added to m, right? This addition symbol makes it seem like it's being added, but that isn't always necessarily true. We have to look at, is this a positive or negative number? Well, it is a positive number, so that means it is being added. So that when I go to make my to-do to undo list, I'm not worried about this operation in between. What I'm looking at is this positive or is this negative? Well, because it's positive, 1.4, that's like it's being added. But if this was a negative 1.4, that would mean it was actually being subtracted from m. And that can be kind of confusing. So again, pay attention to if this number is positive or negative. Well, the opposite of a positive number is a negative number, or the opposite of addition is subtraction. So I'm going to subtract 1.4 from each side to solve this. So there is my step to solve, so now I need to go in and actually do that. So my step to solve, subtract 1.4, I'm going to do that right here. Subtract 1.4 from the right side, which means I also have to do it from the left side of the inequality. So negative 1.4 right there. All right, well now I need to solve it. So 1.4 minus 1.4, that's a 0, so they just cancel out like always. I'm going to bring the m down on the right side of the inequality where it was. I'm going to bring the inequality symbol down exactly as it is. All right, and the last part I need to do this subtraction. So negative 8 minus 1.4. Well, these are all bad guys, so really it's just going to add together and we're going to end up with a bigger negative number. So negative 8 minus 1.4, that's actually negative 9.4. So what I have here is negative 9.4 is less than m. All right, well now we need to come to our number line and we need to label it. So there's a few ways you could go about this. We don't have a nice solid number right here like we did before, a whole number. That made it really easy. So I could either choose to still label by whole numbers, or I could choose to label by decimal numbers. I'm going to choose to label by whole numbers, right? And I'll show you how to graph that when that's the case. So I'm going to start with a number that's close to negative 9.4, all right? And I'm going to choose negative 9, right? Well, then I would need to put some numbers moving towards the right and towards the left. So skipping every other dash, I'm going to count by 1. So negative 8, negative 7, negative 6, negative 5. Then same moving to the left. So that would be negative 10, negative 11. And this would, or excuse me, negative 10, negative 11. And then this would be negative 12, negative 13. There we go. So now we've got our numbers labeled here. So then we need to choose a number to the left of negative 9.4 and a number to the right of negative 9.4. Well, because I labeled by whole numbers, all right, this can seem a little bit tricky. But we really just need to figure out, well, where is negative 9.4? Is it in between this dash and this dash? Or is it in between this dash and this dash? Well, this represents negative 10. This represents negative 8. Well, that would mean that negative 9.4 would be between negative 9 and negative 10. So really, it's right in here. So any number moving to the left of this would be a number I could plug in. So I'm going to choose negative 11, and I'm going to plug that number in. So I've got negative 9.4 is less than negative 11. So is that true? Is negative 9.4 less than negative 11? Well, no, it's not. It's actually greater than negative 11, so this is false. And then I'm going to choose a number to the right of negative 9.4. Well, that actually would be negative 9, so I'm just going to use that one. So negative 9.4 is less than negative 9. Is that true? Well, it's to the left, so yeah, that would be true. So my arrow should be moving towards the right. All right, so the last thing we need to do is we need to go graph negative 9.4, so drawing a circle. Well, again, as we talked about, that's between negative 9 and negative 10, so it's kind of right here in the middle. Then we need to check for an equal sign to see if it's filled in. No portion of an equals to sign, so it's not filled in. And last part, we need to go in and we need to draw an arrow moving to the left or to the right. Well, the right side was true, so my arrow would be moving towards the right, which means everything to the right would make this inequality true. All right, well, we've got one more example here, example C, so I'd encourage you to try that one on your own, then check your answer with mine. So example C says k plus 5 is less than or equal to negative 3. So first thing, where's my variable? It's here on the left side. What's happening with it? It's being added by 5. So my to-do, what they're doing is they are adding 5. So to undo that, I need to do the opposite of adding 5, which is subtracting 5. So there is my step to solve. So I need to go in, I need to subtract 5 from both sides of the inequality. So underneath where they added 5, I'm going to subtract 5. Then on the opposite side of the inequality, underneath where they have negative 3, I'm going to subtract 5 as well. Well, now I need to solve it. So as we talked about before, a positive 5 and a negative 5, that just cancels out. We're left with just the k on the left side. I need to bring down my inequality symbol as it is, which is less than or equal to, and then negative 3 minus 5, that's bad guys and bad guys, so they join together to make a team of 8 bad guys, so negative 8. So I've got k is less than or equal to negative 8. Well, again, I need to go back in and I need to label my number line here. So I'm going to start with the number I know, which is negative 8. I'm going to count by 2's, skipping every other dash, so negative 7, negative 6, negative 5, negative 4. Then moving the other direction, negative 9, negative 10, negative 11, negative 12. And then I need to choose 2 points, one to the left of negative 8 and one to the right. So I choose negative 10 first, and we're going to see if that comes true. So negative 10 in for k, which is less than or equal to negative 8. Well, negative 10 is not equal to negative 8, but it is less than negative 8. So this is true. So my arrow should be going to the left, but let's just check a number to the right to make sure. So I've got negative 6 here. I'm going to plug that in. Negative 6 is less than or equal to negative 8. Well, negative 6 is not equal to negative 8, and it is also not less than negative 8. So this is false. All right, well, last part, we need to go in and draw our graph. So negative 8 is our starting number, so circle at negative 8. All right, any portion of an equals to sign? Yes, there is. So that means that we have a filled in circle, and then draw our arrow moving towards the true side, which was the left side of the inequality, of the number line. All right, well, this is how we solve linear inequalities when using addition, or excuse me, subtraction here. So if you have any additional questions, please let me know. Otherwise, you should have what you need to continue on in the chapter.